All right. So hello, good afternoon. Hope you're all having a good conference here. So yeah, as you mentioned, I'm a tools engineer at Jive Software. And I'm going to talk a bit about systems orchestration with MCollective. So, first off, what is orchestration? I'm sure everyone can make some sort of an educated guess as to what it would be. But I'm going to just kind of define it as the automated coordination and management of multiple systems. So, the level of complexity can definitely vary, but that's kind of what I want to start with. So I'm basically going to focus on some ideas and concepts and how they relate to using MCollective here. So here's an orchestra. So I'm showing this because it's an orchestra and it seemed kind of obvious with orchestration. And so in an orchestra, every musician has this predefined music that they're going to be playing. And these musicians are also grouped into these sections based off of what instruments they're playing. And then finally, there's this conductor kind of leading everything and running the show. And so relating this to systems, I tend to think of each individual musician as like a node. And then the groups are the various groups of nodes running different applications and whatnot. And then you have this conductor who's, the orchestrator, the guy running the thing. And so anyway, all this put together is going to give you the beautiful symphony, hopefully. So orchestration, in contrast to configuration management, orchestration is a bit different than configuration management in that configuration management, you really just are focusing on a single node. And most applications these days run on multiple nodes, and so that's why we need orchestration. But if you happen to have everything that will run on just one node, you can just use Puppet because you've got your one-man band that's kind of doing everything for you there. All right, so again, my name's Devon. I've been a Unix sysadmin for about 10 years, or actually over 10 now. I got my start originally working on automating the management of a bunch of AIX nodes. And to do this, we had written this in-house configuration management system of sorts. And basically what it let us do is write these shell snippets that we would test in a lab and then ship out with an execution tool to actually run on the lab nodes. And then once everything was validated, we could push it out to production and not actually have to manually do anything on these systems. So the tool definitely wasn't the most straightforward. There's a lot of rough edges. And I do bring it up only because it really kind of gave me the frame of mind for how I want to be managing systems as far as being able to test and validate and push it to production and kind of automate things. And today, stuff like Puppet and MCollective make me extremely happy to be a sysadmin because I don't have to manually create all these tools anymore. And these are nicer than what I was using. Something I want to be sure to mention here is Ari Pinar. Thanks a ton because he's the contributor or he's the creator of MCollective. And he's generously donated it to us to use, along with a variety of other tools. And not only has he given us these tools, but he's a generous helper as well. On the MCollective IRC channel, I sometimes wonder if Volcane isn't a bot because he's pretty much always online and instantly responding. And yeah, anyway, so seriously, thank you, Ari. Good stuff. So, okay, now on to some of the meat of what we're going to be doing here. So all the examples use MCollective. I'm going to actually be doing a live demo here, and I'm going to be hopeful that it works out, but it's a risk. Some of the ideas and stuff might translate to other tools, but this is definitely focusing on MCollective. So some basics on MCollective here. MCollective uses a client-server model of sorts. It's definitely not your parents' client-server model, where you have a whole bunch of clients that all connect into a single server. With MCollective, you have a server, and basically the server is just the MCollective daemon that's running on all of your nodes. You also have magical middleware. And so the middleware is basically just some pub/sub middleware that all of these server daemons connect into, and they subscribe to some channels and topics. And this is as opposed to a lot of other orchestration tools that might be using SSH as the transport. So here we have, servers connected to middleware. This isn't actually going to do anything yet. We need the one last key piece for MCollective, which is the client. And so the client is basically a program that allows you to connect to the middleware and send messages to the topics that all of your server daemons are subscribed to. And so at this point, we've got the whole thing connected. And conceptually, this is basically this is basically MCollective. And so MCollective, it's important to realize that it's more of a framework than anything else. And it's a framework that's providing this basic platform for you to use. To actually leverage this platform and do useful things with it, you need to add plugins. And that's kind of the key with MCollective. Plugins are totally crucial. They're what's going to give you all the functionality that you're going to be using this tool for. I'm going to talk about four types of the four primary kinds of plugins I'll mention here are agents, which are providing tasks for those server daemons to actually do on a node. There are security system plugins, so you can get things like authentication, authorization, encryption, all that security goodness. There's connector plugins, so you can shuffle around different middleware and use different kinds of middleware if you choose. And finally, there's data plugins, which give you more advanced ways to filter or group or identify nodes within MCollective. You can create your own plugins to enhance pretty much any aspect of MCollective, all these different subsystems. But for the most part, you probably aren't going to have to start from scratch creating all your plugins because there's a vast wealth of plugins out there that already exist that do probably most of the things that you're going to be interested in wanting to do. So we'll talk a little bit about the agents because those are useful plugins here. These are the main things that you're going to be wanting out of MCollective. And so agents, so I'm only going to cover a few of the common ones, and you can get an idea of where to go from there. So the first one I'll mention is the package agent. And this package agent actually leverages the Puppet package type on the back end. So it has all the same kind of platform support that you would end up having with Puppet, which makes it kind of nice. So let's check out a quick demo here. So I'm running the, oh no. Oh wait. There we go, maybe this will work better. I say that because this takes a long time to spin up, and if it didn't work, that would ruin everything. Okay, so let's check out the status of the rsync package. And so this command that I'm running here is MCO, which is the client command. Package is the agent application that I'm trying to run, package. And then rsync is the package argument, and the action is going to be status. So it goes across, hey, look, I have 6 nodes here, and all of them are missing rsync. So let's see if we can install it. And this is the part that I'm not sure about because the networking here has been kind of spotty. But here, how about I grow it a bit more? Ah, OK. So yeah, OK, the networking is definitely bombing here. But so the command that I typed to get the status was this right up here. And this showed me the status that the package was gone. To actually install it, I did an install and ran into a failure because of broken networking. So what this would have done is installed the package, and then I could have removed it again. But for the sake of the demo, we'll just move on. So that's basically it with packages, right? Status, install, remove. The next one is the service agent. So the service agent is like the package agent in that it's leveraging the Puppet service type. So you get that multi-platform support with MCollective for free. So let's take a look at a service example. All right. So same thing here, running the MCollective service SSHD status. And in this case, every node is running SSH. So as I mentioned, it's using middleware as the transport and not SSH. So you can actually do something like stop SSH on all your nodes and see that it's actually stopped on all the nodes. And you can still interact with them and manage them via MCollective because it's out of band of SSH. So we'll start it back up. That way they're in a happy state. All right, so we got it stopped, started, and we're in good shape again. And so that's basically it with the service agent. Moving on, there's a Puppet agent. And so the MCollective Puppet agent manages the actual Puppet agent that's installed on your nodes. It lets you do things like run Puppet on your nodes with options like no-op or tags or environments. It'll even run Puppet across all your nodes with a given concurrency. So you can do a nice scale, balanced Puppet run across all your nodes. It can give you reporting information on your Puppet runs, and it'll even let you manage Puppet resources directly from the command line using a Puppet RAL. So let's check out the Puppet agent. So first, let's check out the status here. And we see these guys last ran Puppet 5 hours ago. So let's run it on all the nodes. And let's run it, say, 3 at a time. And so I do the MCO Puppet run all 3. And so it goes through the discovery. It finds all the nodes that it's going to execute on. And then it actually starts running them 3 at a time. So we've got the first 3 started, and it's sitting and pausing, waiting for the next ones, waiting for one to finish before starting the next one. And so on we go. And hopefully it doesn't take long, and there we are. So if I do the status again, you can see that they just finished a few seconds ago. So in addition to status, you can also get a quick summary with a count. And that's useful from a high level. And another interesting one here is the summary. And the summary is kind of slick because it has these little sparkline graphs. The usefulness is, I don't know, maybe from a high level it could be useful, but definitely not accurate data from a graphing perspective, but it can be interesting. But something to note about this here is that I'm running MCO Puppet summary, and this Puppet is an application within MCollective that kind of gives additional features to what the agent is doing in the background. As an example, I can run these commands directly with the agent without any of the fancy stuff in front of it by using the RPC interface. So we'll go MCO, RPC, Puppet, and this summary command here is actually executing the last run summary command of the agent. And so let's take a look at that. So lots of different output than that summary was. So basically, this is all the information that the agent is sending back to the application. And the application is taking all this information and parsing it into those nice graphs that we see there. Another interesting thing that I'm really a fan of with this is that all of these RPC, or by using this RPC interface, you can add a -J flag and send all of your data out in JSON, which makes it really useful and easy to pipe this and use this through other tools because it's all very easily parsable. All right, and so that is the Puppet agent. Oh, wait, actually, no, I'll show you one more thing, the interesting bit with the Puppet RAL. So I'll briefly show you another agent here. So we'll do MCO file manager. And this is a really simple agent that lets you touch a file, remove a file, or get stat on a file. So let's see the status of /temp/Devon. The file doesn't exist. So we can use the Puppet RAL to actually create that file as you would any other Puppet resource. So we'll go MCO Puppet resource, which is going to be the action. And then the parameters for the resource are the resource type. So we got a file. Imagine it like you're writing a Puppet manifest, but without any of the syntax. So we've got a file. The name of it will be, let's say, tempdevon.txt. And let's say content is going to be blah. So this should create a file with content of blah on all those nodes. And hey, it looks like it did something on all those nodes. So we'll go back to the file manager status again. And we see that that file is there. If I actually look at the file on this node, I can see that it says blah, just like I wanted. And so that's, it's extremely flexible. The Puppet resource option, that is, you can do execs. So you could run arbitrary code on things, which makes it kind of interesting and kind of leads in to the next bit here. So it's kind of important to realize that the MCollective agents aren't just shipping shellcode out to nodes. I mean, the agents have some structure in them. They have these predefined actions, and they do some input validation so that you have, safe, trusted things. And this kind of structure is pretty important with MCollective just because it's so fast. when I had used that previous like shellcode snippet shipping system, if I started shipping something out that was breaking things, it was easy to like Control-C or kill a process or something and really limit the damage. But with MCollective, it really doesn't matter if you're running it across 5 nodes or 5,000 nodes. You're going to get pretty much the same experience. So, because MCollective is fast, when you break things, you break them fast. So, thank you. So the key takeaway is, don't just be shipping shellcode out because it's fast. It's dangerous. Don't be that guy. So going back to the orchestra, agents are providing the musical notes, these individual actions that this orchestra is going to be playing. Let's talk about filters. When you run MCollective commands without any filtering, as I've done before here, it just runs across all the nodes in your collective. It might be what you want, but probably not for most things. And so filtering lets you narrow down the scope of what nodes you're actually going to be executing across. There's quite a number of ways to filter, and more than I'll end up covering here, but some primary things are by collective, by identity, by facts, by configuration management classes, by data. So to get into some of these, collectives, I couldn't find an interesting picture for this yet. I don't know why, but anyway. Collectives aren't really strictly filtering, but they can definitely help you achieve some filtering. They are the most basic way to group nodes within MCollective. By default, the MCollective config ships with just one collective called MCollective. But you can add subcollectives and additional collectives, and you can use this to do some sort of layered grouping hierarchy if you want to. And you can connect your nodes to any number of different collectives. So at Jive, where I'm at, we have this hierarchy of subcollectives. It looks something like this. It's actually even more complex. But in this case here, every node is a member of a containing collective that identifies, kind of the general purpose thing that this node's life is. And then the geography, and then finally a global collective. So if we want, we can execute actions globally. But typically, we will target down something more specific. And the reason you would do something like this is that the way the agents actually, or the way MCollective is actually leveraging the middleware is by subscribing every agent to a specific topic for its collective and its agent name. So like the package agent is going to be subscribed to package.uscustomer, package.us, and package.global. So there'll be 3 channels. And the nodes, if you have nodes that aren't subscribed to certain collectives, then when you run a command that targets that collective, none of those nodes are even going to see the messages. So it really gets you kind of like restriction and security based on which groups and which topics nodes are actually subscribed to. So I don't actually have an example of using collectives because my demo doesn't have collectives defined. So it's just MCollective. The next thing, though, is identity filtering. One more thing about collectives, actually. So the collectives, again, are just a string, a comma-delimited string in the configuration file. And it's something that you would end up wanting to manage using like Puppet, for instance, to just add the collectives that you deem required for certain nodes. So anyway, OK, back to identity. So identity, you don't have to plan ahead for and add to a config file or anything. It's all dynamic. And it's basically just a regular expression filter based on the host name or the FQDN of a node, the identity within MCollective. So this, I do have an example on. So in this case, we can just do an MCO ping, which will do a simple ping across the nodes through MCollective to make sure it's up. But what we have here is the identity of all the nodes. And so we can filter across those. So let's do a ping using the identity filter with anyone that's called, let's say, node 2 or 3. And then I only hit those 2 nodes. And so that's basically it with the identity filtering. The other kind of filtering, or another kind of filtering, is going to be facts. So facts are provided by Factor. I'm guessing most people here are familiar with Factor. If not, it's just a simple key value list of useful information about a system. So MCollective can access these facts either by executing Factor directly or by looking at like a facts.yaml cache of different facts. I'll touch on that a little bit more in a second. But let's actually look at some facts on a node. So to do this, I'll show another tool here. So you have there's a built-in MCO inventory application. And so you give it a identity, and you get some information about this node as it relates to MCollective. So simple MCollective server statistics, information about what things are loaded up into it, and then finally, all the facts on this node. So you can filter across any of these facts, and you can filter using a regular expression of any of these facts. So a quick example on this is let's do filter on the IP address ETH1. And let's say any node that has 192.168.2.3 or 4. All right, I just happen to have these memorized right now. So we do a simple filter, and we find nodes that have a fact that matches this. All right, so a little bit more about that facts.yaml. There's some common recipes that you can use to generate a facts.yaml. It's basically just a sorted thing, and it's something that you would use Puppet to create. The reason you would actually want to do that rather than executing factor, or the primary reason, is that these recipes include Puppet top scope variables as well. So if you have an ENC, or if you're setting data in like your site PP, or setting variables, you end up having access to those variables from MCollective, and you can treat them like they're facts, which can be a pretty powerful thing, especially if you're doing interesting things with an ENC. The next filtering is going to be with configuration management classes. And these are just Puppet classes, or even Chef classes would work. And so you can filter your nodes based on whatever classes are showing up in like the Puppet classes.txt. So a quick example here. We'll go back up to this inventory output that we showed. And there's actually a section for configuration management classes. And so these are all the classes that that node happens to have defined on him. So let's do a filter on, let's do a ping. The class is going to be, let's look for someone who has the role of middleware. And we found one node that has the role of middleware. And so that's basically it with the class filtering. If you're using roles, or if you're using like, classes for different things, which you are most likely, then you can use this to like only target web servers, or only target database servers, or whatever. The last kind of filter that I'm going to talk about are data filters. So data filters are basically MCollective plugins that allow you to extend the kind of things that you're actually going to be filtering on. So rather than just these simple static like facts or configuration management or whatnot, you can do something more interesting and more dynamic. So in an example here, we can go back up to that inventory output, and we see we have a number of data plugins. We have, process, service, devstat. Not going to show all of them, but let's take a look at, say, the process one. So let's ping any node that has a process called Redis server. And I think exists is the syntax. So the unfortunate thing about the data filters is that the syntax is kind of obtuse and tough to remember. But if you're doing stuff programmatically, then maybe it's not such an issue. So in this case, this command is going to actually look at the process table on all the nodes, and only nodes that have a process that exists called Redis server will actually respond. In this case, we have one node running a Redis server. That's our middleware box. This is the one that I'm actually logged into here. And if I look, I can find that, yes, indeed, there is a Redis server process. So that can be a pretty powerful way to do some filtering with MCollective. I think another quick short example on that one. There's a Puppet data filter. So you can do something like, ping the guy who has a Puppet resource, let's say file temp / not there, because it's actually not there. And you can say managed is true, and that means it's a file that's managed by Puppet. In this case, temp not there is not managed by Puppet, so hopefully nothing gets found. And nothing is found. But just like any of the other filtering, if there was something running that, it would be reported here. So going back to the orchestra again, the filters are basically letting you locate this one section that you want to have, locate the players that you want to give some direction to. So that was great and all, but let's actually use it for something like not just looking at stuff. So let's set up an example here where, let's say we have 2 nodes that we have a process that died on. So let's stop SSHD on 2 nodes. Found 2 nodes, stopped it. So if we look at the status of SSH across all the nodes, we can see that, hey, look, we have 2 nodes that aren't running SSH. So, you know, let's get a little bit further into it. Let's actually only operate on nodes that are nodes, not the middleware. Oh, wait, nodes, not middleware. Okay. Or how about just node? Okay, so out of our nodes, we have 3 running and 2 that are not running. So we want to take action on those 2 that are not running, but we don't want to take action across the board with everything. And so let's use a filter to only start SSH on nodes that are not actually running SSH. So we'll use the data filter for the service. And the service is SSHD. And it's stopped. So let's only find nodes that have it stopped and start it back up on them. And so it should only try to start it on 2 nodes here. And that is the case. And if we look at our status of our nodes again, we see that it's running across the board. So you're going to be using, you know, multiple or compound filters and whatnot to actually be doing things with MCollective, most likely. So when you're using it, you're basically that conductor, like telling one section to do something at a time. So it's close, but it's not actually orchestration yet because you're not really doing a whole lot of orchestrating. You're just getting one thing done. So an example of what orchestration would actually be would be like a rolling restart of a service across your nodes. You could definitely do something like, you know, MCO service, let's take SSH again, SSHD restart, and it's going to run across all your nodes. And, you know, let's say actually we're restarting Apache. If we run MCollective to restart Apache, all of your web nodes are going to go down at the same time, and that's probably not what you're going to want. So MCollective does have things like batching options to where you can say only execute on one node at a time, sleep this amount of seconds between execution or between nodes. But still, if you end up shipping a bad config file, you're just going to slowly take down all your nodes. And at the end of the day, you might not have a job. So, excuse me. So anyway, what do, right? So the fix is basically to write some glue code around MCollective to actually do the interesting things. You know, it could be as simple as just a bash script, right? Where you say, hey, let's find all the nodes here. And once we find all the nodes, let's, you know, actually restart one node at a time. Let's give it a second to make sure it gets restarted properly. And then we can say, you know, is it actually restarted? And something I'm going to be sure to mention here is that this -j, you know, is giving us JSON data. And I'm using jgrep here, which lets us do awesome grepping and displaying of JSON data, courtesy of Peter, who's here in the audience. Yeah, so with this, you're going to be able to, you know, check the status and move on to the next node only if things are actually restarting the way you want them to. So we actually have this simple script here. And let's run it. And so it's doing this simple rolling restart, validating before it moves on. And so, you know, this is the way that you're actually doing some level of orchestration. The complexity of this, you know, you could make it do things across multiple services. multiple types, the amount of logic that you need for your orchestration is, the limit's up to you for what you need. In addition to being able to use shell scripts to do this stuff, you can also use MCollective out of Ruby code. And so this is a partial example because I ran out of room here on the slide, but we have it on the demo here. But this is basically, doing a discovery for guys who are nodes. And from there, we're saying, let's restart this service. Let's check it 3 times. And if it's still not started after 3 times, let's, exit with an error. Otherwise, we'll continue on. So if we run this, the output should look exactly the same as the shell script example because it's doing basically the same thing. And so that MCO Puppet command, for instance, is using the Puppet application to do smart logic. Like you can do that run all to run that to run Puppet with a given concurrency across all your nodes. And the way it's able to do that is with this kind of logic in the application. And so when you start leveraging MCollective and writing your orchestration stuff, you can write them as MCollective applications so that you can leverage them out of like MCO application name do this. But so that's basically it for as far as what I've got. So any questions? Yeah, could you go up to the mic? Or I could repeat if you.
Let's see, is this thing on? There we go. I was curious if you had a comparison between MCollective and something called Fabric, which is essentially a Python API for SSH and creates easily scriptable deployment patterns with a lot less overhead compared to MCollective. And I was just curious if you had any comments on that in terms of getting MCollective set up versus just having an easy SSH library to run various commands on whatever server you want, given certain credentials, et cetera.
Sure, yeah, we've actually, at Jive, used Fabric and MCollective. So we've run into issues with Fabric where like we might have like SSSD or something or SSH get into a funky state on nodes and then we're unable to manage them completely. And so MCollective is nice because it's all out of band from that. But yeah, no, you're definitely right as far as the burden of like implementing something new with MCollective is a little bit more because you have to write your agent and distribute your agent before you can start using it. And I think that's part of the reason why some people end up using like shell agents with MCollective because you can just ship stuff easier. But you end up with a lot more risk doing something like that. And same thing with the Fabric method. Your code might not be nearly as tested as something else. But good policies would make either tool equally usable, I think.
Hi, can you speak to the like the authorization, auditing, logging subsystems? Because like you said, it's pretty damn dangerous, right?
Yeah. So the setup we use for auditing and authorization are all plugins that are offered by Puppet Labs. So we use action policy for giving certain users access to certain agents. So like we have a NOC user. They're not allowed to run a lot of things. We have like an architecture user, and they're allowed to do other things. And so it's action policy that we're using for that. We're also using, for authentication, we're using Puppet certificates, the SSL plugin. So basically, we have a script which will generate an SSL cert from our Puppet master for an individual user, and then we'll distribute that to all the nodes. And as far as auditing goes, we end up logging MCollective to a log file, and it's a central logging system picks that up, and so we have stuff to watch that. All right. I guess, oh, yeah.
How would you describe the differences between MCollective and Salt?
I've never used Salt. I don't know. Yeah.
How does MCollective deal with actual output from whatever commands you're running, shell commands to grab both standard in and standard out? And how does that parse that if I wanted to get a report on whatever script that I wanted to push out to MCollective?
Okay, so the question is, how does MCollective deal with output and errors or whatnot from shell scripts that it might be executing? So I can actually show you the code for probably a simple agent. Let's see. Let's see if anyone's using this. Okay, so there's this run built in, which basically lets you execute a shell command, capture standard out, capture standard error, and jump the output or not. Let's see. And so when you use it, you end up sending this data into your reply from the agent. And when you're executing the agent, you end up with that data string. Like if we look at the RPC output, let's see. So this output has, this data string that it gives back. And so reply ends up being part of this data string. And you would end up parsing that. Like from the application part of it, or aspect, or code, you would then just basically read data out of reply, either error or whatnot. And you could let the agent just execute things and not care about how it finishes, and then have your application do all the parsing to say, hey, this is bad, this is good, this is whatever. Does that kind of answer? Okay. Yeah? So the question is, okay, so the question is how to get MCollective bootstrapped on a node. So the way we end up doing it is our provisioning tool, once we're done provisioning a node, it will execute Puppet, which will set up MCollective on that node. And not until Puppet has run will MCollective be available. And really, unless there's some way to package the stuff, I mean, it's config files and packages in a service that we want to use Puppet to manage. So that's our dependency there. Yeah. The question is there specific versions of Puppet that only work with specific versions of MCollective? I don't believe so. I've never had any kind of issues with dependencies, and Peter's shaking his head no. It tells me probably not. Yeah, so there might be certain aspects of the Puppet agent, like if you're using the Puppet Labs Puppet agent, certain functionality might not work on older versions of Puppet, but in general, things should just work. All right. Well, one last thing to show here. I think I'm obligated to. But Jive, we're hiring. We work on MCollective and Puppet and interesting things. We have over 10,000 nodes in our MCollective installation, so it can be interesting. Thank you.